So today we are going to discuss this topic of smart grid technologies. What is meant by smart grid? So in the topic we are discussing the smart grid, key challenges in smart grid implementation, smart grid architecture and the components. So why smart grid? So we are connecting all the networks are together from generating station to the end user. So now we can see this is a generating station. We are using a transmission line, and again we are interconnecting through the distribution line. The distribution means it is coming under substations. Again from the distribution we are connecting to the end users. End user means it is a our consumer is the end user. So here everything has been done in the manual operation. So here we need to proceed to the automated one. That's why we are preferring the conventional grid into the smart grid. Here there are the different types of failures will happen in the smart grid. One was a brownout and another one was a blackout, another one was a load shedding. So brownout means there is a voltage fluctuation which has happened in the area. It suddenly causes temporary loss in the system. So immediately you can see there are 1 hour or 2 hour there is a no supply will available in our home. In the case of blackout, you can see there is a loss of electrical power network supply to the end users. And in the load shedding, so we know in Kopraka, in the last every Saturday there was a load shedding operational takes place. So they will stop the supply for 3 to 4 hours or 6 to 7 hours, and immediately they will give the supply in the next time schedule. So the load shedding is to the practice of stopping the supply of electricity to the particular area for a period of time to balance the supply and demand which is happening in the generating station. So it will happen in all the places. Why smart grid? So here there is a advanced electricity generation and advanced information metering, monitoring and management, because we need to supply and demand has to be balanced, and we need to ensure the stability and the safety of the system. And here the another one advantage was we are able to use the FIT use of renewable energy sources. In next, what are the components it required to upgrade the conventional grid into smart grid? We need sensors, smart meters, and all the sensor and smart meters are interconnected through the wireless communication. And next, we need a artificial intelligence and data science to accumulate the data and predict the data for the future result. In the case of smart grid, here you can see these are the thermal power plant. This is a that is a nuclear power plant or some other power plant which is using a fuel to generate the electricity. So these are called as a non-conventional. There is a conventional source of energy. There is a traditional method which involves to generate the electricity. If I am saying the smart grid, you can see I can able to integrate the renewable energy sources into the centralized grid, and accordingly I can able to utilize the efficiently use the renewable energy, and it can be supplied to the factories as well as the homes and as well as the cities and office and as well as the ecological vehicle. Ecological vehicle means we can say simply it is a EV, electric vehicle. We are using electric scooters, cars, everything in the charging of electricity. So here, what are the challenges in to set up the smart grid? One was the old infrastructure, another one was the high investment, and another one is a cyber attack. So these are the challenges we are going to be facing in the corresponding method.
Have been used by power plants to produce the electricity we use every day. The grid is a network of power lines and substations that carry electricity from power plants to homes and businesses. Today, the grid has problems. It needs updating and is running at capacity. When power lines break or power plants can't produce enough power, blackouts can occur, and that's a problem that can cause fatalities. At the same time, today's grid often relies on a single power source and doesn't provide detailed information on usage, making electricity difficult to manage. To address these problems in the past, we simply built new power plants. But now we can work towards sustainability and reduce our dependence on fossil fuels by using a smarter grid. Here's how. The smart grid means adding sensors and software to the existing grid that will give utilities and individuals new information that will help them understand and react to changes quickly. Let's say a tree falls on a power line and 1,000 homes lose power. With the current grid, utility employees often physically reroute power, which takes time. With the smart grid, sensors and software would detect and immediately route the power around the problem, limiting the issue to fewer homes. And there's more. The price of electricity changes throughout the day, but we can't see it with the current meters on our homes. It may be expensive during peak hours and cheap late at night. With new smart meters at your home, you could set your dishwasher to run when power is cheap. This provides more control of your energy bill and helps prevent blackouts at peak hours. The smart grid also means new ways to use renewable energy. Power generation can now be distributed across multiple sources, so the system is more stable and efficient. It's this ability to communicate and manage electricity that makes the grid smarter and helps us avoid burning more fossil fuels in the future. The smart grid is still a few years away, but soon we'll be able to manage our energy bill, help the environment, and help the economy by making more informed decisions about how we use electricity.
So from this you can able to understand how we can use the smart grid and with the help of smart grid what are the advantages will happen. So if I upgraded the old infrastructures with the help of sensors and wireless networks, I can able to reroute the supply immediately, as well as you can analyze the bills during the peak time. Accordingly, we can able to use our electricity appliances in our home. The definition of smart grid. Here you can see the definition of smart grid is it uses the information. It was a two-way communication and cyber secure communication technologies and computational intelligence in the integrated fashion across the electricity generation, transmission, substation and distribution and consumption to achieve the system in clean, safe, secure, reliable and resilient, efficient and sustainable one. So here there is a what is the meaning for the above passage. So it is a look like some definition. So first of all you have to understand the conventional method means it is a the generation station is there. So from the generation station we are using a transmission line to transport the electricity. From the transmission we are using a distribution station, that is a substation, to distribute the energy to the end users. End users means it is a consumers. So now you can see the flow of information will happens only in the unidirectional. So this is called as the traditional one. If I can able to utilize the information from the end users, so I can't. So for example, the generating station. For example, we can say the generating station is utilizing 3 generators to generate the energy electricity. So each generator, for example, each generator will generate electricity of 30 megawatt. So each generator capacity will be 30 megawatt. So G1, G2 and G3 30 megawatt. So the total capacity of the generating station is 90 megawatt is generating. So the 90 megawatt is directly generated and it is sending to the transmission. Through the transmission we are reaching the distribution station, and after that from the distribution station the 90 megawatt is split into the different users. It may be the factories, our homes, our domestics and the commercial buildings, whatever the thing, we are distributing this energy to the end user level. If I am say from 9 a.m. to 6 p.m. the electricity whatever I am generating, I am going to be directly used with the help of those facilities, because it is a working time for all the commercial and all the buildings. So here the maximum load is utilized, but after 6 p.m. most of the commercial buildings and industries are not utilized. So here I can say there is a reduction of usage will takes place. So now the consumption is reduced to 30 megawatt. But actually what happened, we are generating 90 megawatt, but we have without information we are continuously running our generating station and we are receiving 90 megawatt from the generating station. If I have a data So in the evening time we have only 30 megawatt consumption is taken place. So if those data are available, I can able to immediately communicate through the generating station. The total requirement was 30 megawatt. So immediately they will shut down one generator which is in operation to efficient shut down the generator for efficient reason. So now you can, in this scenario, you can see G1 and G2 is running, G3 is in off condition. So it means that it will be becomes the reliable one, and as well as economical wise it is a good one, because we are not consuming any fuel like coal for running the generating station. So the fuel consumption also less, fuel is less, and economically it is good. And again, the maintenance cost also going to be reduced if the machine is off for next to 6 hours. So these are the factors which influences the smart rate. It means that what is the consumption rate which is happening in the end user, it has been communicated to the generating station. So here the smart grid makes bidirectional way to communicate the information to the main head station. So that's why the smart grid is implemented. So that's why we can say it uses the information. It uses the information under two-way cyber secure communication technologies, because the data is more important. No one has to hack the network. So we are saying that it is a cyber secure communication technologies. After that, we need to predict the data. That's why we can say that it is a computational intelligence, and everything has been computed together, and it forms a generation, transmission, substation, and distribution and consumption one. So if the what is the output of those smart grid? Now you can see the output of the smart grid is the clean, safe, reliable, and efficient and sustainable one. So these are the examples and the definition of the smart grid. Now you can see this is a conventional electrical plant. So the generating station, the values, it generates 90 megawatt, and it has a generator 1, generator 2, generator 3. So what we have seen in the previous scenario, 30 megawatt, 30 megawatt. So it is totally transmitted, and it reaches the distribution station. The total 90 megawatt is splitted into all the users, domestic, commercial, and industrial purpose it is uses. So here the the information only flows in one direction only. If we are talking about the smart grid, the information will passes in the bidirectional. So what is the consumption is going on, how I can able to reduce the cost of the generating plant. So all those information will be available with the smart grid. So here, what is a smart grid concept? So aging of the conventional network has coupled with the few emergence technological of applications. It means that we are going to integrate the sensor and as well as the smart meters in all the places to collect the information, and as well as we can able to monitor the information. Again, what are the things it will affect? It relates to the political and environmental factors. So one is the environmental factors. We know that an environment has to support for those kind of electronic components. And next one is the political factors. And third one is the liberalization of the electrical market. It means that if the smart grid is evolving, now we are using a static bill method. It is the constant pricing method we are using. The fixed pricing method we are using in nowadays. If these technologies are introduced, there will be the dynamic billing prices will take place based upon the load peak and load demand and load supply. And again, it will increases the motivation and inclusion of the consumers, which as a player to the smart grid. As a player means the more number of entrepreneur will place into the market, they can able to generate the renewable energy source, and they directly integrate it into the grid, and they can supply the powers to the government as well as through the private also. So this is the reason behind the smart grid in from the conventional grid. Now, what is the difference between the conventional and the smart grid? So the first point is communication. Here it is a one-way communication. In smart grid it was a two-way communication. Next one is the customer interaction metering. Here everything, the reading is available in the meter. The people has to come to your home on every month, and they have to record the meeting. They have to get the reading, and they have to enter into the system manually. Everything has to be done in the manually. So if we are going for the smart grid, everything has been recorded. All the data are immediately transmitted to the one network communication technologies. And next one, operation and maintenance. Here the manual equipment check has to be done, but here we are implementing the sensor in all the posters, transformers and transmission line. So here we can able to monitor remotely, and we can able to predict, and a time based maintenance can be possible. Next here generation is a centralized, because so whatever the electricity generating in all the places, we have to be come to the grid, and after that only it is going to be distributed to the all the places. Here centralized and distributed. The meaning of distributed means there is an integration of renewable energy sources will be possible. So the renewable energy sources can be integrated and they can be distributed. So that's why we can say it is a centralized and distributed. Again, the power flow control, it is a limited one because it is a manually operated system. Here it is a comprehensive and automated. It means that the system can take care of the network automatically, and it is going to be performed with the programming knowledge itself. And next one is the reliability. Reliability means the prone to failures, outages. So whatever the problem happen on the electrical grid, so it has to be recorded manually. But in the cases of smart grid, everything will be recorded automatically into the system, and through the DBMS, we can able to predict the next event which is going to be happen in the electrical grid. So that is the main advantage. We can able to predict what is going to be happen in the next. And next one is the restoration. Restoration following disturbance. For example, any outages problem in our line, the post, the electricity man has to come our post and they have to recover all those things manually. If the smart grid is there, it is a self-healing mechanism. If any fault is going to be happen, it is immediately going to be trip off, and after that it will be restore automatically with the help of the equipment which is available in all the posters. And the topology of the network, we can say radial. Here it is a network. So what is the smart grid basic infrastructure? So the smart grid basic infrastructure consists of 4 components. The first one is the electrical power system, communication and information system, intelligent production system, and electricity marketing system. So what is the basic infrastructure diagram? This is a basic infrastructure diagram. So here you can see the arrows which indicates the communication and information links to the various electrical power system components, and these arrow will represents the interfaces between the intelligent production device. Intelligent production devices means we are using a intelligent electronic devices. It is a IED. So these devices we are using, it incorporated the sensors, and after that we are using a smart meters in all the places, in the homes as well as in the transformers. All the places we are going to install these smart meters to record all the consumption data in all the places. So here the first component is the electrical power system. In the electrical power system means how the generation will takes place, and the transmission and distribution system. So these are the flow of the electrical grid. Here, if the smart grid, these are the conventional one. If I am talking about the smart grid, these 3 things will be integrated together with the actual grid. Here intelligent production and automation will take place. It will senses the fault, immediately it will disconnect from the system and isolate from the faulty location, and again it will be automatically enabling the function to ensure the continuity of the supply. Here, whatever the happenings which is happen in all the stages, the generation to transmission, transmission to distribution, here the communication and information system will take care of all the things which is communicated to the substation as well as the generating station, and there have a local dispatch center is there, LDC is there. There also they will supply the information to the LDC. Whatever the event which is going to be happen in the system, immediately it conveyed to the head office in the simple language, and it is also going to be recorded with the system. So what is the use of those data? We can able to make the static pricing into dynamic pricing. So here the marketing system means we can able to introduce the dynamic billing system into the market, as well as we can able to introduce the new aggregator into the market. So aggregator means it is like an agent of renewable energy. They can directly introduce the renewable energy generation into the centralized grid. Here the conventional. So next in related to the smart grid, we are talking about the conventional and smart metering. The conventional metering means the conventional meter we are placing in the home, which has to be taken by the EB man manually. They will record the reading manually, and again they have to enter those data into the system. The whatever the data they are integrating into the system, it will be showing to the database. The database is for example, every district has a database. So for example, here the Kopraka Taluka is there. So likewise, whatever the Taluka, they are entering all the data. It is sending to the Ahmednagar district. For example, Ahmednagar is our district. So here, whatever the data which is entering into the system data is directly sending to the database, which is able to view in the Ahmednagar. So this is a conventional metering system. If I am talking about the smart metering, we are installing the smart meters in all the home. No person has to come to your home. Through neighborhood area network or wide area network, we are connecting these smart meters, and it is interconnected with the networks, and it has been processed with automated data through the network cable itself. So whatever the energy you are consuming, it has been recorded by the smart meter. Those information directly sent through the internet cable to the database system. So there is a no players going to be play between the your reading and all. So not only the homes, so the wherever the transformers are installed and wherever the post is there, accordingly they can able to check the distribution data and the consume data. So we can able to prevent the theft which is going to be happen in the particular area also. So it can be directly sent to the database. So there is a no person is going to be act as a third party to come to our home to record all those things. When the smart meter is installed, all the data is sending through the networks like internet. So what is smart meters? Smart meters is a two-way communication methodology to the gateway or a home area network controller. The gateway allows the transfer of smart meter data to the energy suppliers and distribution network operators and other emerging energy service companies. So here, if any complaint is going to be happen in the home, it can be rectified automatically by the particular agencies. If any fault is going to be happen or anything is going to be happen with your homes, so there is no need to make a call. Just to have an emergency push button is there. You can press the button. It can be automatically inform those information to the particular parties, and also they are going to be record all the data for predicting those things for the futures. For example, to 2023. So from Jan to December, they are going to record all the data. So based on the data, they can able to easily predict how much generation it needed for the next year. So from the generation, they can able to understand what is the infrastructure they need to develop. So these other things can be done automatically with help of those data. And short-term benefits. So here we can say energy suppliers and metering operators, they can able to record all the data automatically. Long-term benefits means we can able to predict the information by assessing those data. So here, what is the block diagram of smart meter? The smart meter which is going to be installed in our home. There are the different blocks of that. First one is a signal acquisition. Second one is a signal conditioning. Third one is a analog to digital conversion. Fourth one is a computation. Fifth one is a communication. So what is the function of signal acquisition? The function of signal acquisition means it is going to acquire the system parameters continuously, the voltage and the current which has to be sent to the system. So now you can see. So this is the line, electrical line is there. The voltage and current line, the voltage and current, these are the two parameters we need to measure constantly. So these signal has been acquired in the signal acquisition system, and this is sent to the signal conditioning. So what is the function of signal conditioning? Signal conditioning will reduce the noises in the signal, because whatever the data which is acquiring means it is acquiring the signals. So these signals are in terms of analog only. analog. So it reduces, so here the analog signal has a lot of noises during the recording process. So I need to reduce the noise level in the particular recorded analog signal. So the accurate signal is sent to the block 2, the signal conditioning block. In the signal conditioning block, I have to increase the actual signal and reducing the noises which is present in the signal. After that, the actual signal is sent to the A to D block. A to D means it is a process of conversion from analog to digital. Here the sampling theorem is applied. So these analog waves are converted into these kind of dots. It means that if you see, so there is a dotting mechanism. The sampling theorem is applied. Here the analog signal is converted in terms of digital. So here you can see the total signal is split into values of zeros and ones. So all the values are mapped with the zeros and one of the signal magnitude. What is the magnitude across the x and y axis and the time division axis? This is a magnitude. This is a time division. X axis is the time axis and y is the magnitude. Based on the magnitude, we are going to map those values with the zeros and one. So entirely the analog signal is converted into zeros and one, and again we are sending to the computation block. So computation block is to store the data, and as well as it is going to be predict the information. So for example, and I am receiving the voltage value of 40 and current is 2 amps. So what happened in the computation block? It stores the information 40 volt, 2 amps, and it makes the timestamp. What is the time now? 9 o'clock. So at time 9, my voltage was 42 amps. Again the next measurement will take place 1.9 amps. The time was 9:10. So whatever the information it is receiving from A to D, it immediately captures those data and makes the time stamping and send the data through the communication. So communication means we have to send those data to the database networks. So database system. So whatever the data we are receiving, here it processes the entire digital data and putting the stamp mark on the particular computation data, and again we are sending the information to the communication block. So this is the functional block of the smart meter. How we are acquiring the signal and how we are reducing the noise and how we converting the analog into digital, and what is the role of time stamping with the computation block. After that, after all the process is completed, the smart meter tries to transmit the information to the gateway network. Gateway means the gateway is the usually interface between the home network and the neighborhood area network. So through the gateway, we are sending the information to the particular the database systems. Here we can see the input and output through the LCD information, how our meters will have. So in energy meters, you have a display information, time and how much electricity you are consuming. All the informations are available. So likewise, the LCD display is available in your smart meters. As well as the small keypad or touch screen is available for the human machine interface. It means that to select the information and as well as to communicate the emergency situation, you can use those options, and also you can able to choose the payment option in the particular smart meters also. You can directly select the payment option through the QR code. You can directly pay the bill without any interference. So here we are talking about the communication. So how it has been communicated. One is the wired option, another one is the wireless option. Wired option means we are using internet cable. So public switched telephone network, it is a PSTN. Another one is a power line carrier which is available in the transmission line. Another one is a cable modem and Ethernet. You know the Ethernet connections how we are using. Another one option is wireless option. Wireless option include Zigbee, infrared, GSM, GPRS, CDMA, cellular. So these are the method we can able to connect the smart meter into the database system. Either we can go with the wired option or either we can go with the wireless option. The most affordable option is the Ethernet is the most affordable option. So that's all about the smart grid. So in the today's session, we are discuss on what is smart grid and the key challenges in smart grid, and the difference between conventional and smart grid. Third, we have seen the smart grid infrastructure components, and the fourth one is the smart meters. So these are the topics we have seen in the particular video. Thank you.